Hey everyone, Geophysicist Stefan Burns here. We had a magnitude 7.5 earthquake, the strongest yet in 2026, strike the island chain of Tonga north of New Zealand on the 24th of March. We see these seismic waves propagating across the entire globe. When you have an earthquake of this magnitude or larger, these waves go across the entire planet. They are quite strong. We even see reflections from the other side. You'll notice that there is a focusing of these waves later on near the antipode, the exact antipode of this quake being Algeria. We've had a lot of big activity in the Mediterranean recently, most notably the strongest earthquake in 10 years to strike Italy, a deep magnitude 6. So I would be looking at that area for the next few weeks for potentially a reflective seismic response. That is certainly possible, magnitude 6.5 or greater. But this story is much bigger than just that. We're really interested in some larger global dynamics here, because when you get big earthquakes, you create these massive pressure waves, these shock waves, as we can see here. And well, Tonga is famous for its volcanic islands. You have active subduction occurring at Tonga, and there are a bunch of submarine and aerial volcanoes there that have been very active over the past few decades. Most notably, the strongest volcanic eruption since Krakatoa in 1883 occurred there in 2022. And so a question that a lot of people are asking is, are we due for something like this once again, or perhaps even bigger as a result of this heightened earthquake activity that we are seeing in this region? Because this isn't just this most recent 7.5. There have been bigger earthquakes that have occurred there in the recent past, and there is this accelerating trend with higher magnitude earthquakes going back to 1980. So we've only been getting more and more earthquakes in this location of the globe since then. This eruption here, the Hunga Tonga Hunga Ha'api eruption, it was a long duration going from December through January, but this blast wave right there, specifically January 15th of 2022, a VE5 to VE6 eruption. We're looking at satellite imagery here. This shock wave went around the entire globe, produced a massive tsunami. 6 people were killed by this. Thankfully, this island is so remote that more people were not injured or killed. Thank God. But this was a big eruption. Again, VEI5 to VEI6. What does that mean? It means that there was either greater than 1 cubic kilometer of material up to greater than 10 cubic kilometers of material. So this is, again, a big eruption, has had some pretty significant impacts on our climate because the amount of water vapor injected into the stratosphere was tremendous. A part of the atmosphere which typically has very little water, water being the strongest greenhouse gas, is water vapor, and that has a cooling effect, which then has a heating effect on the troposphere below. So this is one reason why we've been having such a warm climate overall for the past few years. We still have enhancements of water in the stratosphere. But with all these earthquakes occurring, it's certainly possible that this was not the big event for this region, but perhaps even just a precursor event to something larger. So let me show you our earthquake map so we can really see what's been happening over the past week here. We were forecasting a larger event to occur in this region, as some others were as well that watch this daily. That's really the key for earthquake forecasting, is to see when you get anomalous activity. Often that's a sign a higher magnitude earthquake is about to go. Well, we had these 3 magnitude 6s that popped off in at the very northern end of the Tonga Islands, south of Samoa. And we see it was a 6.2, 6.3, 6.2. There was also a magnitude 6 roughly in that region earlier than this time frame here, but just by about a week or so. So there was quite a lot of activity here. Then we get this magnitude 7.5, as you can see. This has created a whole cluster of earthquakes. We see a 5.2 there, 4.6, 4.9, 4.6. There should probably be a magnitude 6.5 aftershock for this. That's certainly possible in the coming days. Typically, you'll get a aftershock that's 1 magnitude less than the main shock. So this being a 7.5, we're not seeing a 6.5 in this location, though again, we did have these 3 magnitude 6 plus earthquakes here. We see all on the 22nd of March. So that was the first clue that there's something happening here. And if we look at the historic data, we do see these seismic bursts that occur in quick succession, not just in one location, but across this entire zone, which is interesting because if you take that in consideration, it means that there are larger geologic forces at play here. It's not just one single part of a fault slipping, but a larger force pushing upon this part of the globe, then causing a distributed seismic release. Now, let's look at what this eruption looked like back in 2022. Here we have imagery from January 14th, taken by the Tonga Geologic Services. So this is before the big shockwave eruption, all right? And this is already looking apocalyptic. But again, this is before the big eruption. We see earthquake lightning there. You'll see this explosion come out there from the side. This thing's just waking up. Again, it started up in December 2021, but then it really started accelerating into January 14th, and then on the 15th was the big shock wave. We can even zoom forward here. Check out what happens just a few minutes later. So more volcanic lightning. Again, this is before the big one. So these submarine volcanoes can be very active on the day of that main explosion there, the VEI 5 to 6 eruption. This actually created a electrical impulse picked up on the other side of the world in Europe, a strong burst of energy in the Schumann resonances. Some unusual electric currents were detected from this. We can actually see the shock wave created by this with our satellite imagery there. So here we see the explosion on the 15th of January, and then we pick up this atmospheric and shock wave and these gravity waves that travel across the entire globe. So just like this magnitude 7.5 earthquake triggering these seismic waves to propagate out everywhere, so too can volcanic eruptions trigger significant pressure and energy waves going across the planet. Here we see ash from that eruption back in January of 2022, taken from the International Space Station up in the atmosphere, the stratosphere. So this wasn't as much of a cooling event as you would think. Typically at the volcanic eruption, you get a lot of sulfur dioxide and ash, and that creates a cooling effect. Overall though, this was a high water vapor eruption because it was a submarine volcano. So a lot of that ocean right above the volcano got volatilized, basically vaporized up into the stratosphere, carried up with that ash column moving up. And then there was a very low sulfur dioxide content overall, the percentage, compared to a normal volcanic eruption. And again, this being the biggest volcanic eruption that we've had since 1883 with Krakatoa. So we had Pinatubo, 1991, that was big. Mount St. Helens, 1980, but these overall are very small compared to Hunga Tonga Hunga Ha'api back on January 15th, 2022. Let us look at our historic earthquake activity because this is really kind of where the story clicks into place. So let me show you this. I have the earthquakes loaded up here going back to 1980. And it's this combination of data, the earthquake data, and also seeing that we've had now the biggest volcanic eruption since 1883 in this region that kind of paints this story that, well, we may have something bigger or similar to occur in the near future. This whole area overall is fairly young geologically. And so if there are these larger changes taking place for the zone, we can expect that that is eventually going to manifest as heightened volcanic activity like we saw just a few years ago. So here's our latest 7.5 right there. Let's search for largest magnitude. We see back here around Fiji, it's kind of difficult to see some of the locations because there are so many earthquakes here. We're seeing all earthquakes in a selected zone magnitude 6 and greater. I really wanted to show high resolution what this area looks like. But we see this 8.2 right there. That was 2018 to the north and to the west of a lot of these islands and volcanoes for Tonga. Look at the depth, 600 kilometers down. So when you have a mega quake that is deep, like that 2018 quake, and you see that's the largest in this, 46-year time frame, effectively, 45, 46-year time frame, that pressure wave is coming up from the bottom. So all the plumbing that exists for these volcanoes going down into the asthenosphere, the mantle, that shock wave is propagating up the entire way. So I think the timing of there being a 8.2 megaquake at 600 kilometers down, just about 4 years, not even 4 years, before the largest volcanic eruption since 1883, I think that's quite significant. We also see here 2021, another megaquake, Kermadec Islands. This is further to the south of Fiji. We see 2009, a megaquake. This is Samoa to the north. And then we see one in Tonga here, 2006. So quite a lot. You will notice that there is this clustering at times. So we can go here to newest first and scroll down, and sometimes you'll see this clustering occur. So here's a good example. We had a 6.6 there on the 28th of April 2023. Then on the 10th of May we have a 7.6. Then in June on the 15th of 2023 we have a 7.2. See how that's spread out across this entire zone? Look for the cyan dot as it's moving, right? This is showing that during that 2 or 3 months, there was a larger geologic force pushing up on this area, causing these earthquakes to occur. We see this sort of bursty activity quite often in this area just for this data set going back to 1980. If we had a longer data set, I'm sure we'd see this over hundreds and thousands of years. So it's really quite significant. Let me show you this another way. Here we have our cumulative seismic energy release earthquake chart going from 1980 to 2026, but basically we can kind of say the end of 2025, all right? And so this is cumulative, so it's going to start off low in terms of the energy. This is gigawatt hours there, and then as the earthquakes keep coming in, they add together and it's going to build up. And so as you go further in time, you're going to need a bigger earthquake to move this line up because this is a logarithmic scale, and therefore if you see a big jump in it, like we see here, then you know that that was a big earthquake to shift it up so much, even though we're already at a very high cumulative energy. So again, this is going all the way back to 1980. You notice I have this set for all earthquakes magnitude 7.8 and greater for these markers right there. We see that we didn't have any earthquakes magnitude 7.8 or greater going up to about 1997 or so. Then we get our first one. Then we get a burst right there. See that clustering? This is a longer kind of multi-year time frame, but we get that clustering. Here we get two effectively back to back right here. An 8.2 on the 19th of August. This is 2018. Then also a 7.9 on the 6th of September right there. Here is our 8.1 in 2021 Kermadec, and then we get Hunga Tonga. So see this like effectively ramp up. We have one magnitude 7.8 or greater, then we get three fairly back to back, then we get this double burst followed up shortly later by another mega quake, and then boom, Hunga Tonga right there. And we can examine this from a different angle as well. We can take different decadal periods and examine them compared to one another, look at their cumulative seismic energy and that equivalent cumulative magnitude to see how they compare. So here we have going from 1986 to 1995, that's the first 10-year period. We see this 7.7 right there. This is for all earthquakes magnitude 7.5 or greater. Here we see a 7.6. Our cumulative magnitude, of course, there's a whole bunch of lesser magnitude earthquakes. Again, this is all earthquakes magnitude 6 or greater. Our cumulative magnitude at the end of this 10-year time frame for that location I showed you on Google Earth, it goes to just under 8.2. So that's a lot of energy release over 10 years. We can look at our next one. This is 1996 to 2005. Again, we have an earthquake there, and then we have 2 back-to-back right here. So now we have 3 quakes, magnitude 7.5 or greater, a whole bunch lower magnitude than that, and our cumulative magnitude here goes to about 8.3. So we have 8.0, 8.1, 8.2, actually just a little bit more than 8.2. So more than the last one, all right? So this decade has released more energy than the decade period that we chose before that. Now we go into 2006, 2015, all right? We see here more frequent earthquakes, and this is a continuing trend. We look at our cumulative magnitude there. Now it's getting close to 8.5, but it's more than 8.4. So again, we've increased our cumulative seismic energy release for this decade compared to the prior one and the one before that. Here we have our most recent one, 2016 to 2025. And we have double burst right there. That's 2018. That really jumped it up because of that 8.2 megaquake Fiji. Then we see here the 8.1 Kermadec. I do not have the energy, by the way, for this volcanic eruption calculated into this data set. I just have it marked there. Then we see this 7.6 right there in 2023. Cumulative magnitude getting right up to 8.5. So again, ramping up each time. Boom, 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 getting higher and higher. So this really seems to me, if we zoom out again, that we're on a longer trend here where overall seismic energy release in this part of the globe is increasing across time, bigger quakes, deeper quakes, and this could be the first big eruption of perhaps many. And that was a VE5 5 to 6. So it's a big one, biggest since Krakatoa, but at the same time, on the geologic scale, VEI 5 isn't that big. I think the kind of consensus estimate is about a 5.8. So that'd be about, let's say, 8 cubic kilometers of material ejected. It's, you know, this did not launch 90 cubic kilometers of material. That would be a VEI 6, but at the upper end of that range. So it's probably closer to just bottom end VEI 6, which would be 10 cubic kilometers of material. Well, you could get a volcanic eruption that's 100, 150, 300. That's still tiny. Yellowstone is 1,000. So we have these potentials that exist. And this is really something to pay attention to because of how it can affect our Earth, our climate, and more. Here we can see upper atmosphere water vapor content for 20 to 80 kilometers in altitude, going back all the way to the early 2000s, okay? And we see that it has been trending up. Here's the Hunga Tonga eruption right there. 150 million tons of water injected into the stratosphere. We have started to go down since then. We're still about 50% elevated compared to normal. So this data is updated here, October 2025. So it's not the most up to date, but it's pretty much we're good to go looking at this and understanding the effect of this eruption on the stratosphere, a massive ejection of water vapor to the stratosphere, creating overall stratospheric cooling, disrupting the polar vortex that exists because this water was neatly circulated across the entire globe. It took some time, a little less than a year or so, but eventually that water was circulated across the entire globe, and now the whole stratosphere is carrying that water much more than normal. This is also important because there is an energy imbalance here. So the bigger thing to look at here is, okay, well, why is this area experiencing more seismic energy release over time? Why are we seeing perhaps this big volcanic eruption with Hunga Tonga and perhaps more, right? Well, we're absorbing more energy from our space environment than we have been because there's this energy imbalance. We see our outgoing long wave radiation here. It is increasing because Earth is getting more and more energy, but there's this disparity between them. Here's our absorbed solar radiation, and our energy imbalance is about 1.24 watts per square meter. So solar cycle 25 has been stronger than solar cycle 24, getting closer to that historic average. In this time frame though, going back to the Industrial Revolution 1850, we've done a lot of geoengineering effectively across a whole bunch of different ways. I mean, we have satellites now flying down and burning up and depositing aluminum and other metallic compounds and dust into our atmosphere, our stratosphere. There are weather engineering experiments that are ongoing. Of course, the biggest engineering weather climate modification that's been going on is the use of hydrocarbons releasing greenhouse gases like water vapor, the strongest greenhouse gas, CO2, methane. If you break a hydrocarbon, you're generating exothermic reaction, releasing heat energy that was sequestered for millions of years. This is all solar energy that plants absorbed like 150 million years ago, got sequestered down, converted into hydrocarbons. It's energy neutral until you light that match and you get that explosion, not only releasing greenhouse gases like the ones I just described, but also you're also simply generating heat. At the same time, you have more solar radiation coming in. So our Earth is becoming more energetic. The storms that we're experiencing are getting stronger and stronger. Big Category 5 cyclones, continuous lightning storms. You're getting cyclonic activity at times that you wouldn't expect. Big bomb cyclones and blizzards, and you're having huge temperature swings, or sometimes you get the highest temperature recorded, sometimes you get the lowest temperature recorded, just more volatility overall. And that energy does not stop just in the atmosphere. It really goes beyond that. Here we see an explainer for this Tonga eruption. So here is the volcano. Again, it was just under the surface. Tons of water going up into the stratosphere. Here's where we live in the troposphere, okay? Big tsunami waves going across. This generated atmospheric gravity and sound waves in the mesosphere, extreme winds in the thermosphere and the ionosphere. Unusual electric currents were detected by this. Again, we had a burst in the Schumann resonances that was picked up in Hungary from this eruption in Tonga. So that's quite amazing. And in general, this is Earth's way of regulating herself, you could say. As there's more and more energy coming in, volcanic eruptions, for example, that these electric currents pulsing through the ground surface and the increasing heat loading of the Earth can trigger more seismicity, more volcanic eruptions, and therefore push up more sulfur dioxide perhaps into the atmosphere. This eruption was a bit odd because since it was just under the surface of the ocean, it actually had the opposite effect, whereas a lot of water vapor is injected, not that much SO2, and so it actually had a warming effect. But in general, with a volcanic eruption, you then would have this cooling and you have more sunlight reflected from the sulfur dioxide, and this is one way for Earth to regulate her system. But we're really pulling on these levers in a multitude of ways, and then you still have the main driver of the sun coming in, and that's increasing with its energy output, and well, things could get crazy. So that is where we are right now. This magnitude 7.5 being the latest in a strong sequence of earthquakes across this region. Again, we can look at that right here. We see the region that I selected for that earthquake data that I showed you. Just really here, Kermadec Trench and Fiji, Samoa, this whole area right there. And if we look at our latest data, then we can see these volcanoes that I'm talking about specifically. So we see all these small little island chains. Some of these volcanoes are at the surface. Tofua here, for example. Others are right below the surface, but there is a lot of activity in this part of the world with these small volcanoes, which actually can have very powerful influences on our planet. And I just want to reiterate one more time that the antipode location for this, it is West Africa. The exact antipode is roughly Algeria, but the very close to the antipode is in fact the Mediterranean. And the weeks leading up to this magnitude 7.5, we saw increased seismic activity across Greece, Turkey, and most notably Italy with a magnitude 6, strongest in 10 years. Also a 5.2 ruptured about a week after that. And so I would not be surprised if we see an antipodal quake in this region of the world. It could be really kind of anywhere in here because that's roughly the antipode location. Italy would be a little further north, so a little further off of that exact antipode, but that's the antipode right there. So anywhere in this region there. But Italy is the place that's been showing the strongest response. It's also where we have lots of volcanoes. Interesting that you have that strong volcanic chains on both sides of the planet. You have Campi Flegrei supervolcano right outside of Naples. You have Mount Vesuvius there. You have Marsili volcano. You have Etna. You have Stromboli. You have tons of volcanoes in Italy. You also have the Santorini Colombo volcanic field, well, in Greece in the Aegean Sea. So big volcanic systems roughly at that antipode for Tonga. We could see a response from them on the other side of the globe. In general, what I'm saying here is that this 7.5 is the latest bit of evidence, and this swarm right there is the latest bit of evidence that this area is very active geologically, and we cannot dismiss the fact that we could have a powerful volcanic eruption in the near future as a result. And by near future, I could mean tomorrow. This could also mean 10 years from now. Hunga Tonga showed a tremendous amount of activity leading up to the big eruption on the 15th. Again, this is the 14th, but we first started seeing activity back in December 2021. So it kind of took people by surprise, but we did have a buildup. So if we start to see activity like this in that area, or maybe from like Vanuatu or some of these zones, right? Well, then we need to prepare for those consequences because we are still dealing with this fallout. Now there's been more extreme weather events around the globe. I mean, crazy heat waves, again, more weather volatility. And I think as this energy keeps coming in and this energy imbalance for the globe continues to widen and that energy is not being radiated out, I do think we're going to see more and more events like this because this is Earth's way of self-regulating. And we'll just have to wait and see. So that is your update for today. Thank you all so much for watching, everybody. I've been your host, Stefan Burns. Please smash that thumbs up button to help the channel grow. Subscribe to stay up to date on everything that's happening with the Earth energetically, earthquakes, volcanoes, severe weather, geomagnetic storms. We also, right before this 7.5, had a large coronal hole on the Earth-facing side of the sun. We had a long-duration G2 and G3 geomagnetic storm. So all this is connected together. We look at solar activity, we look at space weather, planetary alignments, cosmic forces, how all that combines together influences our planet. I release videos almost daily. Thank you all so much. Wishing each and every single one of you well. Please take care of yourselves. I'll see you all very soon.